Good afternoon. My name is Karien and I'm joined here by Dr. Christopher de Saxe. We are senior researchers in the CSIR Smart Mobility Unit, working in transport systems and operations. Today I'm going to give you a bit of an overview in terms of our research journey that we have undertaken in the last couple of years to ensure that we have safe roads in South Africa. Road safety is a public health problem, not only in South Africa, but globally. And the cost of crashes in South Africa was estimated in 2015 to be in the region of 143 billion rand. In 2019, that figure has escalated with 30 billion rand. It estimates to approximately 3.4% of the GDP. And those costs are incurred by the road users and their loved ones. Traditionally, we look at the road and the causes of road accidents, looking at three different categories. First of all, human factors, vehicle factors, and then the road and the environment factors. At Smart Mobility, we consider all three factors, but today we're only going to talk about vehicle and human factors. Christopher, over to you.
All right, thank you, Karien. So Karien has highlighted to us the cost of road crashes in South Africa, and I just want to continue on that point in a slightly different direction. If we look at the impact of this on logistics in South Africa. So what you see in front of you is a breakdown of the cost of logistics in South Africa, which in total accounts for about 11% of GDP. Of that, transport is about half, and of the transport costs, road transport is about 83% of that. So a significant amount of money in our economy is involved in road freight transport. And below that you see a breakdown of the different costs involved in road freight transport. So we're talking trucks. And what I want to highlight to you is a lot of these components are closely linked with road safety from a cost point of view. So if trucks are crashing, there's downtime, there's impacts on traffic, there's impacts on the cost that these transport companies pay for their insurance, that they pay for their financing. All of these are closely affected by road safety. And so obviously there's a life and health point of view, which is very important, but this puts it into a new perspective that it really impacts the performance of our economy. Back to you, Karien.
For the next part of the presentation, we are going to look a bit at how driver behavior influence road safety. And traditionally, we used to investigate human factors and especially driver behavior, making use of reactive methodologies, self-reports, mailing lists, diaries, interviews, and specifically for crashes, looking at insurance data, police reports, and in-depth crash investigations. More recently, we've diverted to using a proactive methodology called Naturalistic driving studies and field operation tests on vehicles. And it's a fairly new methodology that was developed in the last 15 to 20 years, and it has been used globally. Naturalistic driving studies is a methodology during which you can unobtrusively observe human behavior. It's the continuous monitoring of the driver, the environment and the vehicle, and it's a rich source of road safety data, generating large amount of quantitative and qualitative data. And we collect this data with sensors, cameras, onboard computers, global positioning systems, and supplement information from questionnaires and interviews. So the type of naturalistic driving data that we collect considers the driver, the environment, and the vehicle behavior. First of all, we provide the respondents with a questionnaire to participate in the survey, to get demographic and knowledge, attitude, and perception information. And from the cameras, we can observe reaction time, gaze behavior, in-vehicle behavior, seat belt use, headway selection, impairments, anything that has to do with in-vehicle behavior. Secondly, we are able to simultaneously look at the environment, at weather, light, adjacent land use, other road users' behavior, and traffic control measures and conditions. Lastly, we are observing the vehicle behavior from the onboard computer, measuring speed, the location of the vehicle, as well as acceleration and deceleration behavior. The CSIR has been involved in naturalistic driving studies since 2010, decoding driving. And the topics that we've investigated include distracted and inattentive driving, driver behavior in the context of non-motorized transport users, novice driver behavior in comparison with experienced drivers, and then the one that I want to tell you a bit more about, hazard perception development in the learner driver phase. Statistics show that 10% of all South African driver fatalities between the years 2015 and 2018 were young drivers, between the ages of 18 and 25 years. And most of these crashes that were associated with these young people were rollover crashes, which means that they have not yet learned the ability to perceive dangers within their road environment, and secondly, they haven't yet learned to control their vehicles. Back to the methodology. This is a visual representation of the system that we use, and you can see the different cameras facing the outside of the vehicle, the front of the vehicle, the back of the vehicle, as well as the driver of the vehicle. For this project, we instrumented a learner driver instructor vehicle, and we followed 26 learner drivers over a period of 6 months to observe their behavior. In this video, you'll see that the learner driver has to negotiate a very busy intersection where the traffic signals are not working. And what we found was that learner drivers tend to fixate in front of the vehicle. So they don't yet have the ability to perceive dangers in their immediate environment. And as such, they only fixate in front of them. And as you can see with this specific video, they did not observe the vehicles turning from the other side of the road and almost causing a near crash. Why is it important? We've got limited existing data or information on general driving behavior. We don't have information on normal driver behavior in South Africa or everyday driving practices that can be used to benchmark driving. With the naturalistic driving studies, because we have the opportunity to study the vehicle, the person, as well as the environment simultaneously for the first time, it becomes possible to observe interactions and behavior between road users, between vehicles, between the driver and the environment in ways that was previously not possible. One of the key contributions that this methodology makes is that in South Africa we don't have very good crash data, and with this methodology we are able to study traffic conflicts. In other words, being proactive, looking at behavior that can potentially cause crashes, rather than waiting for the crash to happen and then treat the intersection or the behavior. So we can literally prevent crashes from happening. Why is this important? South Africa is part of the United Nations, and we subscribe, or we're a signatory to the United Nations Decade of Action, of which the safe system is the basis for both our national road safety strategy, same as with other countries, and the whole idea with working towards a safe traffic and road system is that humans make mistakes. So we need to incorporate physical and psychological limitations into our road designs and into our vehicle designs, so that these designs absorb human failure, so that humans don't have to die or be seriously injured when participating in traffic. As part of our national road safety strategy and the work that we do to support safer roads in South Africa, we strongly believe that road safety is a shared responsibility, and as such the CSIR is establishing a road and transport safety research centre, and this research will support future solutions aimed at addressing road safety in the next 10 years. Thank you.
Thanks, Karien. So we've seen the research that the CSIR has been doing in driver behavior, which, as we saw, was a big factor involved in crashes. I now want to look briefly at how vehicle design impacts road safety, and particularly heavy vehicle design. So you might have a sense of the state of our truck transport in South Africa. We come across really serious crashes on an almost daily basis, and pretty severe, and they have a big impact on the roads. Now, if we look at the actual statistics, South Africa really does have a problem with truck crashes. The graph at the bottom there shows South Africa's fatal crashes per 100 million kilometers relative to a few other OECD countries, where our fatal truck crashes are almost an order of magnitude above these other countries. So we really do have an issue in the country. What I want to show you now is that obviously there are driver issues involved, there are infrastructure issues involved, but something that's not been taken into account, at least in South Africa, is the impact that the design of the trucks has on the crash safety risk. So what you see in front of you is a graph from a study done overseas, where they looked at one parameter of a truck design, which is called the static rollover threshold, and I'll explain that in more detail later, and what effect that has on observed crash rates in actual on-road data. And they picked up a very significant correlation there. So there definitely is a link between the design of trucks and their crash risk on the road, amongst other risk factors. So what we've been doing at the CSIR for some years is adopting a new methodology for looking at how trucks are designed to be safe on the road. What you see in front of you is a number of what we call performance standards on the right-hand side. I won't go into all the detail, but just summarize them from a very high level. So firstly, we look at the low-speed turning characteristics of trucks, which are quantified through these four metrics you see there. And that affects how safe a truck is at turning at an intersection, for example, not taking out vehicles in the adjacent lanes, not impacting road infrastructure. We then look at very safety-critical high-speed dynamics of trucks. And in this category, you see that rollover threshold that I mentioned earlier. And what this does is it looks at a truck's inherent stability at high speeds. How likely is it to roll over if it has to make an evasive maneuver, for example? And then finally, also important is the drivability of trucks, which affects the ability of trucks to navigate, for example, steep inclines. Because a truck traveling at 10 k's an hour up Van Riemen's Pass actually poses a significant safety risk to other road users. So we look holistically at all of these performance standards to ensure that trucks are designed to be safe. Just to give you an example, this is one standard called Rearward amplification. And on the left, you'll see a video of a truck that has been designed using traditional design principles. And we can see here in the standard maneuver, it's actually unsafe, the rear trailer rolls over. On the right-hand side, this is a similar truck. It's actually been designed to carry more payload, so it's a more efficient truck, but it's been designed using these principles. And as we can see here, this bigger, longer, more productive truck is in fact more stable. So it's really powerful what this methodology can do. Then now just an example of low-speed turning. What you'll see here is a 19-meter long truck performing a turn, and I want you to see how the rear trailer cuts into the adjacent lane there, which is obviously a risk to a car stopped there, or pedestrians or cyclists. Here's another vehicle. It's even longer, but it's designed using these performance-based principles. And you can see it can be designed to perform that same maneuver more safely than the traditional truck. So we have actually been running a pilot project of this approach, this smart truck or performance-based standards approach in South Africa. And we've been monitoring all sorts of metrics from fuel consumption, efficiency, number of kilometers traveled. But importantly, we've been monitoring the safety performance. And what we found is that the PBS designed trucks versus normal conventional trucks operated by the same operators have shown a 41% reduction in observed crashes, which is really, really significant and indicates the impact that this methodology can have. This is just a high-level overview of some of the stakeholders that we've been working very closely with. It's not an exhaustive list, it's much bigger than this, but we're working closely with local universities. We work very closely with the actual transport operators, with the truck and trailer manufacturers, and then of course with the Department of Transport, who is participating in this pilot project. And more recently, we've started looking at working with the insurance and finance sector, which is something I'll go into a little bit more detail now. So through our work, we've been designing these trucks to be safer, but we've also been using this methodology to analyze how current trucks on South African roads perform against these metrics. And what we found from our sample data set is that over half of these trucks are deemed to be unsafe according to these standards, which is a really significant finding. So how we go about applying this methodology is actually quite an involved technical process. It requires sophisticated software packages. It requires a lot of kind of mechanical engineering and analysis and modeling, which is great. And we need that level of accuracy for the pilot program that we're running. However, what we're really wanting to do in the long run is have an impact on the normal trucks operating on South African roads. And something this complicated is not going to be adopted en masse. So what our more recent work is focusing on is creating simplified safety risk prediction tools that industry can actually adopt en masse. So for example, we've done work on developing simplified low-speed truck turning tools. That's something we've done and have developed and we've applied. We've also got simplified tools for calculating the drivability performance of trucks, again, which is being applied currently. And what we're focusing on at the moment, where we think there's a lot of value, is simplified tools for calculating the high speed and particularly the rollover risk of trucks. So just to paint a broad picture of the future we're looking at, is we want these kind of simplified tools to be adopted by, for example, the insurance sector, where they can assess an insurance application from a fleet operator, calculate different risk scores for these different metrics, and come up with a weighted vehicle design risk score, which can then be used to calculate premiums, for example, and which will then encourage fleets in South Africa to start adopting these principles to make sure that their trucks are indeed safe. So just to wrap up, a very quick summary of some of the things that are going on now and where we're going in the future. So this PBS concept, this methodology applied to trucks, is something that, like I said, we've been running for a few years, and we're actually getting close to a milestone where we're engaging very closely with the Department of Transport as to whether these concepts can actually be formally adopted into South African legislation, which would have a big impact on safety in South Africa. Secondly, CSIR Smart Mobility has also started an initiative to develop a focused multidisciplinary road safety initiative in the CSIR. And more broadly, we have a number of projects and engaging very closely with the likes of SANRAL, the RTMC and Gauteng Province, in addition to the National Department of Transport, like I mentioned earlier, to really make sure that a lot of this research gets out there, it's adopted by both industry and by the state. Thank you very much, and we're now open for questions.